Hello everyone. In this class, we are going to discuss about the one more type of the secondary structure of protein, which is nothing but the beta sheet. And here, this beta sheet, it will be having the extended conformation of the polypeptide chain. And here, the beta sheet, it will be having the pleated sheet-like appearance. And here, the structure of the beta sheet is defined by the backbone atoms. And here, the this beta sheet also similar to the alpha helix, it will be having characteristic set of dihedral angles. And here the backbone of the polypeptide chain in the beta sheet is extended in the zigzag appearance. And here in the beta sheet, the two or more polypeptide chains are going to line up side by side. And here in the beta sheet, these two or more polypeptide chains are going to be stabilized with the help of the formation of the interhydrogen bonding between them. And here and between the two or more polypeptide chain, the hydrogen bond is formed because of the presence of the carbonyl oxygen and also the amide hydrogen. And here the hydrogen bond is formed between the carbonyl oxygen of the one polypeptide chain to the amide hydrogen of the other polypeptide chain. And here in the beta sheet, the zigzag structure of the individual polypeptide segments gives rise to the pleated appearance of the overall sheet. And here it will be hang the pleated appearance, and that's why it is also called as the beta pleated sheet. And here the side chain of the amino acid residues in the beta sheet are going to protrude outwards in the opposite direction. And here the polypeptide chains in the beta sheet, it can be parallel or the anti-parallel. Parallel means, so here the parallel beta sheet means, so here the two or more polypeptide chains, and they will be having the same amino terminal and the carboxyl terminal orientation, because the polypeptide chain means it will be having the two distinct ends. So here one end it is called as the amino terminal end, whereas the other end which is called as the carboxyl terminal end in the parallel beta sheet. So here the two or more polypeptide chain, they will be having the same amino terminal and the carboxyl terminal orientation. In the anti-parallel beta sheet, so here the two or more polypeptide chains, they will be having the opposite amino terminal and the carboxy terminal orientation. And here the repeated structure of the repeat period in the parallel and the anti-parallel conformation is having the length of around 6.5 angstrom and 7 angstrom respectively. And here the parallel beta sheets are less stable when compared to the anti-parallel beta sheets. It is because the parallel beta sheets, they will be having the distorted hydrogen bond when compared to the anti-parallel beta sheets. And here these are the structures of the beta sheet. And here in this case you can see, so the single strand of the which single polypeptide chain in the beta sheet, it is called as the beta strand. And here it will be, as I told you earlier, it is having the pleated appearance, pleated sheet like appearance. And here, as I told you earlier, so here the side chains are facing opposite to one another. So here this is which is called as the beta strand. And here the beta sheets or the beta conformation, they will be having the two types, as we discussed earlier. One is called as the anti-parallel beta sheet, and the one more which is called as the parallel beta sheet. In the anti-parallel beta sheet, different polypeptide chains are going to orient in the opposite orientations. And here in the parallel beta sheet, so here the two or more polypeptide chains are going to handle the same orientation of the carboxyl terminal and the amino terminal ends. And here in the anti-parallel beta sheet, so here as you can see here, these dotted lines are it is going to indicate the hydrogen bond. So here the in this case, the interhydrogen bond is formed between the carbonyl oxygen of the one polypeptide chain with the amide hydrogen of the other polypeptide chain, in case of the anti-parallel beta sheet, and even also in case of the parallel beta sheet. And here in the parallel beta sheet also, the hydrogen bond interhydrogen bond is formed between the carbonyl oxygen of the one polypeptide chain with amide hydrogen of the other polypeptide chain. But the difference is in the parallel beta sheet, so here, as I told you earlier, they are having the distorted hydrogen bonding when compared to the anti-parallel beta sheet. And for this reason, the anti-parallel beta sheet is more stable when compared to the parallel beta sheet. And here this is the repeating unit of the anti-parallel beta sheet. So here in case of the anti-parallel beta sheet, the repeat unit is having the length of around 7 angstrom, whereas in case of the parallel beta sheet, the repeating unit entire the length is having around 6.5 angstrom. And here this is regarding the beta sheet. And here the one more structure we are going to discuss in this case is nothing but the beta turns. And here before that, some of the amino acid residues in turns are in loops where the polypeptide chains are going to reverses the directions. And here these elements are going to link the successive runs of the alpha helices or the beta conformations. And here the common examples is nothing but the beta turns. And here these beta turns are commonly they are going to link the two adjacent segments of anti-parallel beta sheets. So here the anti-parallel beta sheets are usually connected with the help of the structures or the terms called as the beta turns. And here this structure it is having the 180-degree turn involving it is having the 4 amino acid residue. And here this structure of 180-degree turn, it is having the 4 amino acid residue where the hydrogen bond is formed between the carbonyl oxygen of the first residue with the amino group of, or the amide hydrogen of the fourth amino acid residue. And here in this case, the central two amino acid residues are not going to form any inter hydrogen bonding. And here the two amino acid residues, which are called as the glycine and the proline residues, are oftenly seen in the beta term because the proline is cyclic structure and ideally suited for the beta term. Whereas the glycine is the small amino acid, and here it will be having the more structural flexibility. And here for these reasons, the glycine and the proline residues are oftenly seen in the beta turns. And here the beta turns are oftenly found near the surface of the protein, where the peptide groups of the central two amino acid residues in the turn, it can make the hydrogen bond with the water molecule. And here there are two types of the beta terms are there, a type 1 beta term and the type 2 beta term. And here this classification it is because of the differences in the dihedral angles of the second and the third residues of the beta terms. And here as you can see here, these numbers include the 1, 2, 3, and the 4 includes the 4 amino acid residues which are present in the beta terms. Okay, so here this classification into type 1 and the type 2 it is because of the differences in the different dihedral angles which is seen in the second and the third amino acid residues in the beta terms. And based on this classification it is made. And here as I told you earlier, so here the hydrogen bond it is formed between the first amino acid residue with the fourth amino acid residue, both in type 1 beta term and also in the type 2 beta term. And here in the type 1 beta term, in the second position, the proline is there, and in the type 2 beta term, in the second position, the glycine is oftenly seen. And here, as I told you earlier, this classification it is because of the differences of the dihedral angles of the second and the third amino acid residue. And here for the type 1 beta term, so here the second amino acid residue it will be having the dihedral angles. The phi angle is around minus 60 degree, whereas the psi angle is minus 30 degree. For the third amino acid residue in the type 1 beta term, the phi angle is minus 90 degree and the psi angle is 0. And for the type 2 beta term, for this second amino acid residue, the phi angle is minus 60 degree, whereas the psi angle is around plus 120 degree. And for the third amino acid residue, the phi angle is minus 80 degree and the psi angle is 0 degree. So here these are the different dihedral angles for the second amino acid residue and the third amino acid residue. Why these two amino acid residues are important means, so here these are the two amino acids where the polypeptide chain it is going to take the 180 degree rotation. And here for this reason these dihedral angles are going to play very important role in the formation of the beta term. So here on this basis the beta terms are classified into type 1 beta term and the type 2 beta term. Thank you.